Transitioning from the numbers that we were just working with now into algebraic expressions, we're asked here to find the greatest common factor. So when we're working with polynomials like we're seeing right here and trying to find the greatest common factor, you're going to have to compare each of the individual terms of the polynomial. So for example, in this very first one right here, this polynomial has 3 individual terms. So you're going to have to compare each of those 3 terms to find what factors they have in common, but then also what's going to be the greatest. So you're going to have to consider any numbers as well as variables in all of these terms. So if you just focus on the numbers or the coefficients of these terms, you've got a 12, an 8, and a 20. So it does turn out that like a common factor would be 2, right, because they're all divisible by 2, but you want the greatest, right? So it does turn out that 12, 8, and 20 are all divisible by 4 at the greatest. So it does mean that the GCF of this entire expression will be involving a 4, but there's more to it than just that. There's also x to the third and x squared and x. So it does turn out that this expression will be divisible by actually 4x, because x is going to be another common factor that's the greatest that's shared among all of them. Now just for this particular example, I kind of want to break this down just a little bit to help you see the connection between what we saw with numbers. So like this very first term right here, if you really broke it down to its prime factorization, it's actually 2 times 2 times 3 times x times x times x. And the next term here is actually, if you break it down, 2 times 2 times 2 times x, and the last term that you see there is like 2 times 2 times 5 times x. So when you do identify common factors, they all have a common factor of 2, but they also actually have another common factor of 2. But then in terms of numbers, they don't have other common factors. For variables, the greatest that they have in common is an x, so you can see that that's clearly where 4x is coming from in terms of a GCF for that particular expression right there. So I'm not going to break that down any further for the rest of these examples. So if you move over to the next one, right here, and if you think about numbers 3, -9, and -21, they're all divisible by 3, and that would be the greatest thing that they're all divisible by. So 3 would be part of the GCF, and then the first term has b to the 4th, the second term has p squared, but the last term is just a constant. It doesn't have a p variable. So that means that p is not going to be part of the GCF because 21 is not divisible by p. So it does turn out that the GCF for that expression is just 3. For the next example, you've got 14z to the third plus 15z squared. So 14, it's divisible by 14, of course, as well as 2 and 7, but 15 is divisible by none of those numbers, because 15 has completely different factors, 3 and 5 and 15. So 14 and 15 don't share any common factors other than a 1, so there's really not really going to be a number aspect to the GCF other than, I guess, just a 1. But then for the variables, one's got a z to the third and one's got a z squared, so both the terms will be divisible by z to the second, because that's the most that they would share. So it does turn out that the GCF for that expression is going to be z to the second power. In the fourth example down here, we've got 10q squared minus 8q plus 7. So when you compare just the coefficients, those numbers, 10, 8, and 7, the only common factor they have is just a 1. So we don't really have to worry about that aspect. And then in terms of variables, like the 7 doesn't have any variables, but the other terms have variables. So there's really not a variable that they're all divisible by as well. So really, I guess the greatest common factor is just really going to be a 1. You can really only divide everything there by a 1. And then for the very last expression there, you're going to see that you've got 6, 2, and 4. So the greatest thing they're all divisible by is a 2. And then you've got some combinations of like x's and y's in all of these. So when you think about the x coefficients there, you've got x to the third, x squared, and x squared. So x squared is going to be the greatest thing they're all divisible by. And then finally you see you've got a y and a y squared and a y to the third. So the greatest thing that they have in common there is just going to be a y. So it turns out that this monomial right here of 2x squared y is going to be the greatest common factor of those terms there.